Hello, welcome to video number 53. This is called the slope of a line. Better hang on, this is a very fast video, so let's get started. Today, we want to talk about just one basic fact, that the slope between any 2 points on the line is always the same. There are many points on a line. Here we have 6 marks. We have A, B, C, D, E, F. Of course, there are many other points we could locate. There are all kinds of points in between those points. In fact, the line has an infinite number of points on it. We could mark points all day if we wanted. The point is no matter which 2 points we pick, if we compute the slope and reduce the slope fraction, we end up with the same thing. Okay, so, all right, now, just to illustrate this, we have 3 different slope triangles. We have a slope triangle drawn between C and D. A slope triangle is what we get when we draw the rise and the run in between 2 points. So I have a slope triangle for C and D, that's the blue one, a slope triangle for B and E, that's the red one, and a slope triangle for A and F, that's the orange one. Now, when we compute the slope using these 3 different slope triangles, it's going to end up being the same. So let's do it and see what we get. So starting with C and D, here we go. Starting at C, we go to the right, 2 units. So the run is 2, and then we go up 3 units to get to D. So the rise is 3. So the slope for CD is 3/2. Okay, that's already reduced, so we're finished with that one. If we use points B and E instead, let's see what we get. So we're going to go to the right. So 1, 2, 3, 4, 5, 6. The run is 6. And let's see what the rise is. How far do we go up? 1, 2, 3, 4, 5, 6, 7, 8, 9. The rise is 9. So the rise and run are different than before, but the fact of the matter is their ratio is the same. When we form a fraction, we get an equivalent fraction. We can divide both 9 and 6 by 3, and when we do, to reduce that, we get 3/2 again. So it turns out that probably any 2 points we take on this line and compute the slope, we're going to get 3/2. Right, let's try again with A and F. So we go to the right. The run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's the rise. So when we form the slope using that slope triangle, we get 15 over 10, which is also equivalent to 3/2. Okay, so when we're using a graph, we kind of have to use nice points because we know where they're at to compute the slope. But technically, if we know the coordinates of the points, it doesn't matter which 2 points we use. The slope is the same. The slope is constant for a line. All right, the reason why is given right here. Is because these are actually similar triangles. Similar figures is something we talk about near the end when we're starting to do trigonometry. We're going to learn what sine, cosine, and tangent are. But we know enough about similar triangles to understand this now. Similar triangles are triangles that have the same shape but different size. And so you can see these 3 triangles, the one with the blue legs, the red legs, and the orange legs, they're all the same shape. They're just different sizes. Similar triangles, their sides have the same ratio. So when I take this vertical side over the horizontal side, that ratio is going to be the same for all of them. So the reason why it doesn't matter which 2 points we pick is because all the slope triangles we get are similar and have the same ratio of sides. All right, so there's a geometric fact behind this property of slope, and similar triangles. Okay, we'll learn more about that later, but you should know kind of the reason why slope doesn't change for a line. All right, here we have a case of 3 points that are not collinear. Collinear means they lie in the same line, so if they're not collinear, then they don't lie in the same line. So we have P, Q, and R. And clearly, this is not a straight line. So what we should see is that they don't have the same slope. Okay, so let's compute the slope for PQ. We go to the right 2 and up 4. So the slope for PQ is 4/2, which is equivalent to 2. If we do the other slope triangle, the blue one, we can tell this is kind of different here. So 1, 2, 3, 4, 5, 6. The run is 6, and the rise is 2. So the slope between Q and R is 2/3. That's already reduced. And we can see that these are not equal. That's because those points don't lie on the same line. All right, so here we go. Time for the journal assignment already. Here we have a line. All these points are collinear. They lie on it. I want you to compute the slopes between the given points and reduce the fractions. And what you should see, surprise, surprise, is that they're all the same fraction. It's because they're all collinear. All right, go ahead and enter this in your journal, and we'll see you next time.